Welcome to Tennessee's At Home Learning Series for Math. Today's lesson is for all our 8th graders out there, though all students are welcome to tune in. This lesson is the 11th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education's website, and I actually have that pulled up for you. Just a reminder, if you'll scroll all the way down and you will look for your grade, and you want to click on the student packet so you can do the work and follow along with the lesson for today. Today, we will be learning about systems of linear equations, and we will be working on estimating solutions by inspection. Before we get started, to participate fully in our lesson today, you will need the following: paper and a pencil and a surface to write on. A calculator is not required, but it may be used to check your calculations. Optional, but really helpful, would be graph paper. If you don't have it, don't worry about it. Okay, let's begin. We are in week 3 with our 8th graders, and we're moving back into equations and expressions this week. Have you ever seen a person wearing a fitness tracker? I usually wear one, but of course today I'm not. They usually look like a watch, and it tells the wearer a lot about fitness and activity. One of the things these trackers are very good at is counting how many steps you've taken or how many flights of stairs you've climbed. They do this, and they use a global positioning system, or GPS, to help determine how far you've gone in miles or kilometers. Some trackers even monitor heart rate by shining a light into your blood vessels and calculating the rate based on how the light is reflected back. That is some sophisticated technology. You can also use this data to find out other things. Let's take a look at the information in this chart, and we're going to write an equation that gives the maximum heart rate Y for a person that is X years old. So here is our table. Remember that X represents the age of a person and Y represents the maximum heart rate. Here's what you should have. Y equals 220 minus X. What is the meaning of the slope and the y-intercept in this context? What did you think about? I noticed that 220 is the y-intercept, and this seems to tell me that the maximum heart rate, this is the maximum heart rate for an infant. Also, the slope of -1 tells me that the heart rate decreases as a person gets older. So we're going to use this scenario each day as we get started this week. Now, are you ready to dive into some systems of equations? Okay, let's get started. So we'll look at 3 graphs of different systems of linear equations. Remember that a system of linear equations is just 2 or more linear equations that we are comparing. A graph of a system of linear equations is just 2 or more linear equations displayed on the same coordinate plane. Here is the first one we're going to be looking at. Here we go. What do you notice about this system? How are these lines related? Do these lines cross each other? Exactly, they cross one time on the graph, right here. Now, what do you notice about the slope of each line? Right, the slopes appear to be different from each other. Now let's take a look at a second one. What do you notice about this system? How are these lines related? Do these lines cross each other? Right, they don't cross, and they don't look like they would, even if we extended these lines even further than what we have on this graph. Do you remember what type of lines these are called? If you said parallel lines, then you're right. Now, what do you notice about the slope of each line? What do you notice about the slope of each line? Right, since the lines appear to be parallel, they have the same slope. But what is different about these? If you started thinking about different y-intercepts, then you are correct. Let's look at a third scenario. Now, this is a little more challenging visually, but what do you notice about these two lines? Right, when I showed you both the lines, they are actually the same line on the graph. So what does that mean about their slope? True, if the lines are the same, they must have the same slope. And now the y-intercept? Exactly, those are the same as well. Each of these situations represents one of the possible outcomes for a system of linear equations. So let's look at all three together now. There we go. So if you notice in the first situation right here, we see that the line crosses at one point and one point only. And it shows it right here. So we say that this system of linear equations has one solution. The solution to a system of linear equations is any ordered pair that makes both equations true. In this case, the intersection of the lines is the point with the ordered pair that makes both equations true. So in this situation, right here would be my solution to this system of linear equations. Now, in the second situation we looked at right here, we see that this system of linear equations are parallel and they never intersect. We say that this system of linear equations has no solution. So I'll go up here and label this one solution. And the solution is the point where they intersect. Since these two lines are never going to intersect, we say this has no solutions. There are no ordered pairs where the equations are true. Finally, let's look at the third situation. We see that since these lines are actually the same line, this means that every point is the same. And therefore, we say that the systems of linear equations has infinite solutions. There are infinite number of ordered pairs that make both equations true. So when you're looking through these solution types today, I want you to remember these key points here. I'll cover that. So these are the key points that I would like you to remember. If the equations in a system of linear equations have different slopes, then they will have one solution. So different slopes, one solution. If the equations in a system of linear equations have the same slope but different y-intercepts, they will have no solution. And then finally, if the equations in a system of linear equations are the same one or they have it's the same exact equation, they will have infinite solutions. So if you want to write this down or take a picture of that, these points are going to be super important for you moving on in this series. Okay, so let's think about this in context. Harrison and Mia each buy X number of comic books from a store that sells them for $5 each. Harrison also buys an action figure for $15, and Mia buys a different action figure for $12. Could they spend the same amount of money Y and buy the same number of comic books? Let's first remember about what we need to know about writing linear equations from a description like this. We know that X is the number of comic books bought and Y is the total amount of money spent. We know that Harrison spent $15 while Mia spent $12 on an action figure. So we can write the equations like this. Now that we have a system of equations written, let's inspect this system by looking at the slopes and the y-intercepts. We're going to look at these key points and see if we can use them to determine the solution type. Okay? So, what do you notice each equation has the same, and then what do you notice is different in each equation? Okay, if you said that the slope was 5 and that it's the same in both, then you are correct. Now, what does that mean about the number of solutions to this system if they have the same slope? This means that either both equations are parallel and have no solutions, or they are the same line and have infinite solutions. So how will we distinguish between which solution type this is? Exactly. If we check the y-intercepts for both equations, then we will know if these are the same line or if they're parallel lines. So we see that these two y-intercepts are different. That means from our first definitions up here that this would have no solutions because they have the same slope but different y-intercepts. So what does that mean in the context of this situation? In this situation, it means that Harrison and Mia cannot purchase the same amount of comic books and spend the same total amount. Okay, let's look at a third example. Here's a system of equations that represents the amount of money that two people spent at two different grocery stores. So in this situation, we're looking at the amount of cheese X and the amount of tomatoes Y. So we have 6X plus 2Y equals 12, where the cheese was $6 a pound and the tomatoes were $2 a pound. Then we have 12X plus 4Y equals 24, where cheese was $12 a pound and the tomatoes were $4 a pound. Let's see if we can determine by inspection how many solutions there are to this system. So by inspection, we need to look for the slope first. However, if you'll notice, these equations are not in slope-intercept form. We're going to need to transform both of these to slope-intercept form. Or y equals mx plus b. So let's transform the first equation this way. So I have 6x plus 2y equals 12. The first thing that I'm going to do is I'm going to move 6x. Notice that it's positive. So in order to move it to the other side of the equal sign, I've got to subtract it. So I have 2y equals, now I cannot combine these because they're not like terms. One has a variable and one doesn't. So I have negative 6x plus 12. Notice I kept the sign that was in front of them, and that's how I wrote this. Is this in slope-intercept form yet? No. Now we need to get rid of this coefficient 2. Again, if I want to get rid of this and move it to the other side of the equal sign, I've got to do the opposite. Right now, y is being multiplied by 2, so the inverse of multiplication is division. I'm going to divide each term by 2. And when I do, I have y equals negative 3x plus 6. So that is the first equation that I rewrote. Okay. So if we do the same thing, we're going to transform the second equation, 12x plus 4y equals 24. I want to move 12x over. It's positive, so I'm going to move that over by subtracting it. So I have 4y equals, I cannot combine these, they're not like terms. So I have negative 12x plus 24. And again, I need to get rid of this coefficient this coefficient 4. So I'm going to divide each term by 4. And when I do, I get y equals negative 3x plus 6. So when I rewrote this equation in slope-intercept form, this is what I get. Now, what do you notice about both equations? Right. Both equations represent the same line. The slope is the same, it's negative 3, and the y-intercept is the same, it's 6. So let's think back. What does that tell us about the number of solutions to this system of equation? If you first thought that because the slopes are the same, that the lines were parallel and therefore no solution, you were on the right track. But remember, we have to check both the slope and the y-intercept. So in this case, the y-intercepts are also the same. So if you said that this system has infinite solutions, then you are correct. Let's look at a few more and you work along with me. Okay. I'm going to walk through one more for you. So let's just look at this system of equations here. All right. The first thing we notice is that the second equation here is not in slope-intercept form. So we're going to need to transform it. Let's walk through that process together. So first thing that we're going to do, going to write out 5y minus 15x minus 20 equals 0. Now I want to move both of these terms to the other side of the y-intercept, the other side of the equal sign. So I'm going to do that by using the inverse operation of both. So I'm going to add 15x plus 20, add 15x, add 20. So when I do that, I get 5y on the left side of the equal sign. I get 5y on the left side of the equal sign, and then I have positive 15x and positive 20 on the right side of the equal sign. So notice when I move those over, I just change the sign of both of them. Okay, is it in slope-intercept form yet? No, now we need to get rid of that coefficient of 5 by dividing each term by 5. So I have y equals 3x plus 4. So I just rewrote this equation here. So now we see that the second equation, once it has been transformed, has the same slope as the first equation, but the y-intercepts are different. So notice they've got the same slope, but different y-intercepts. How might people make a mistake with that? Right, they might just see that this second equation, it has a 4, but notice the y-intercept is negative 4 here. The y-intercept is positive 4 here. So since they have the same slope, they represent parallel lines. Let me backtrack. Since they have the same slope, but they don't have the same y-intercept, they're going to represent parallel lines. And that means that there is no solution to this system of linear equations. Okay, let's work through another one together. Let's look through this one here. Okay, how many solutions does this system have? All right, what do you notice about this system? Are we ready to inspect the equations by looking at the slope and y-intercept? What do you think? If you said that we need to transform these equations to slope-intercept form, then you are correct. I'm going to walk through the first one with you, and then you're going to do the second one. So I'm going to start with the first equation, negative 5y equals negative 9x plus 10. For this, I'm going to divide both sides by the coefficient of y, or negative 5. So when I do that, I have y equals 9/5 x. Notice they were both negative, so that made that a positive 9/5. And then positive 10 divided by negative 5 is negative 2. So when I simplified this first equation, here's what I have. All right, you take time and simplify the next one. Okay, so you should have transformed this equation to y equals negative 2/4 x minus 1. Or we could simplify negative 2/4. So we have y equals negative 1/2 x minus 1. Now let's look at the slopes of each transformed equations. So we're looking at these two here. Are the slopes the same or different? Right, they are different. They are definitely different. So what does that tell us about the solution to this system of equations? Yep, this system has one solution. Great job. Now here's one for you to try mostly on your own. Let's cover up our previous work. All right, here are the equations in the system. We have negative 5y equals negative 8x plus 4, and 15y equals 24x minus 12. So go ahead and see if you can determine the solution type of this system of equations. Okay, how did that go? Did you get these equations once you transform them? We should have y equals 8/5 x minus 4/5, and y equals 8/5 x minus 4/5. And how many solutions do we have to this system of equations? How do you know? Right, this case has infinite solutions because the equations have the same slope and the same y-intercept, or represent the same line. You are really getting this. Keep going with some independent practice. Let's try this system of equations here. Are the equations in a form that we can inspect or look at the equations to find the slope and y-intercept? If you said no, they need to be transformed to slope or y-intercept form, or y equals mx plus b, then you are right. Let's walk through each transformation. You can solve it along with me. So let's transform this first equation here. We have 2x minus 9y equals negative 5. Going to subtract 2x. So I have negative 9y equals negative 2x minus 5. Going to divide each term by negative 9. So when I transform that, I have y equals 2/9 x plus 5/9. Here is my first equation. Okay, let's transform the second one. So I have 4x minus 6y equals 2. Going to subtract 4x from both sides. I have negative 6y equals negative 4x plus 2. Going to divide each term by negative 6. To do that, I have y equals 4 over 6x minus 1/3. So here are my two equations. Now don't forget to simplify any fraction. So I could simplify this fraction to 2/3. So here is one equation and here is the other. So let's look at both equations in slope-intercept form. What is the slope of this first equation here? If you said 2/9, then you're correct. Now, what is the slope of the second equation here? If you said 2/3, you're also correct. What does that tell us about the system since the slopes are different? Right, because the equations have different slopes, the lines will intersect at one location. Therefore, they have one solution. Great work today, students. Today we explored estimating solutions to systems of linear equations by inspection. I hope you are making connections between slope and y-intercepts and solutions to systems of equations. After this lesson, you will have a few problems to practice on your own on our website underneath 8th grade math. Good luck and do your best. I have really enjoyed inspecting systems of equations with you today. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.